And all right, cool. What's going on? So somehow my camera's not working today. What's up, guys? And hello, YouTube land. It looks like my camera's not working, but we're going to continue today with SAT Khan Academy problems live. And so now I'm going to jump to screen share, and we're going to get right into it. So let's begin. Today we're solving percent problems. I got the first one already loaded up. Let's take our screenshot. And percent problems are good because it's sort of a relatively, it's kind of a bit of a relatively simple concept in that you often learn how to manipulate percentages when you're in pre-algebra, maybe even before. But these problems can be pretty tough. Let's see, these ones, maybe these ones in particular aren't, but there can be some tough percent problems depending on how they ask the question. All right, so let's get into the first one. A college writing seminar increased its size by 50% from the first to the second day. If the total number of students in the seminar on the second day was 15, how many students were in class on the first day? Some of you may be able to do this mentally. Let me just show you how to think about it. So here's our first day. Okay, and how do we represent a 50% increase? 50% increase, think about it like this. If you have $100 and you have a 50% increase, it's going up by 50% of your original. So we basically, in order to represent that, you multiply your original by 1.5, not just 0.5, 1.5 to get your new final, which is $150. So here we have an original. It's increasing by 50%. So we're multiplying it by 1.50 or 1.5, either way, equals 15, okay? So now we got this. Now we can divide both sides by 1.5. We can type 1.50, same thing, okay? What is 15 divided by 1.5? You can use a calculator if you want. I'll just tell you it is 10. 10 times 1.5 is 15. So like I said, you know, some of these can be, I guess these are pretty easy, or that first one was pretty easy, but we can just sort of jump right in, solve it quickly, go to the next one. Let's look at this one here, number 2. And let us see. It's cool. I got one of my 6th graders actually in pre-algebra is about to start learning SAT math, which is totally doable. You can learn this stuff early, way earlier than you think, and start getting familiar with the test questions. It's pretty cool. She's already knocking out some high-level exponent problems. All right, in 2005, the USGS conducted a survey to investigate water usage in the United States. The following table shows their findings. If 3.8 billion gallons of water are used for domestic use per day, approximately how many gallons of water are used for irrigation? Okay, where's irrigation? In a problem like this, they're saying 3.8 billion gallons are used. That's crazy if that's true. It probably is true. Per day. So this total of all of this stuff is going to add up to 3.8 billion. And now we're saying, what is it used for irrigation? Here's irrigation, this guy. So irrigation is 31%. And remember, guys, on Instagram, jump on my YouTube channel. You can see the problems actually being solved. YouTube, search for Scalar Learning. You'll find me there. So we're going to take 31% of 3.8. Now, you can use a calculator. I'm not going to because I just simply don't have one right now. I don't feel like pulling it out. So we can simply multiply 0.31. See, it's a great trick. You take the percentage and you turn it into a decimal. You move the decimal spot twice, and then you just multiply it by 3.8 billion. You know what I'm going to do? I'm going to make this into 3,800 million. Okay, so this represents 3,800 million. So just remember that, because I think all these are going to be, wait a minute, what? 118 billion. These are larger than this. Okay, hold on. Oh, now I see. I made a mistake here. I read this incorrectly. Domestic. Let me erase this. Almost made a huge mistake. Domestic is what they give us. Domestic is 1%. Oh my God, that's so crazy. All right, now this makes more sense. So domestic is, which is 1%, is 3.8 million. And now we're trying to find 31%. Well, guess what? This is actually an easier problem. It's almost kind of the same way I was doing it, fun, oddly enough. So we take, so if 1% is this guy, we just take 31 of these 1%. 31 times 3.8, we get our answer. So 31 times 3.8, and we can multiply this out. 8, 24, 0, 3, 9, 8, 7, 11, and it's 117.8 or 118, because I say approximately 118 billion. See, I misread. Can happen. Got to be careful. Must be vigilant. All right, let's take this one and take a look. So you can see actually the ones we're looking at so far haven't been overly complex. I think the more complex percentage problems tend to be hybrid. And hybrid problems are where they mix percentages with another math concept, maybe a higher level math concept from the advanced passport to mathematics. A construction crew is made up of 8 men and the rest women. Okay, 8 men and X women. If 40% of the crew were men, okay, how many people were in the crew? All right, check this out. We're going to use, I'm going to do it a special way. We're going to use proportions. So 40% were men. That means 8 over, some of you guys might say 8 over X equals 40%. 8 over the total, which is men plus women. Okay. 8 over 8 plus X. Actually, we don't even need to do that because we're not trying to find the women. We're just trying to find the people in the crew. So we can actually, let's say X is just total. So let's make life simpler. This will work too, actually. It would just be one added step. So X equals total equals 40% over 40 over 100. This is it. You got this proportion, you could cross multiply. We go, this guy goes here and this guy goes here. Here we got 40x. Here we got 800. And then we divide by 40. And we got 800 divided by 40 is 20. So that means there are 20 people in the crew. There are 12 women, just so happen to be 12 women, but we don't care because they're not asking that. Let me just make sure, yeah. Sure I didn't read it wrong. You get these ones wrong if you make a slight reading mistake, and it's such a shame. It's such a shame. Okay, let's go back here. It's funny too. They when I heard the College Board speak a few weeks ago about the new SAT, they did mention that they try to use English that's not ambiguous, that's clear, so there's no misinterpretations. They gave different examples. Like, for example, they said the SAT doesn't, it always uses a subject. It never uses sentences where there's no subject. And I mean, it's true. I'm sure they do stuff like that. But then also, I mean, I think quite intentionally so, they do try and make the questions a bit convoluted with overly technical scientific jargon, stuff like that. But a movie fanatic has amassed a giant collection of home movies, some on DVD and others in older VHS cassette mode. If the fanatic has 308 movies on DVD, how many total movies are in the collection? It's the same process as last time. 308 over a certain total. And 308 comprises, look at this, look how beautiful this is. You literally just set up your percent proportion just like this. They're saying 308 is 31.3% total, and the total is 100. You see how they match up like that so nicely? So now we just do a little cross multiplication. Boom, boom. We get 31.3 equals, what is that? 3,800. And then we just, oops, forgot the X. And then we divide both sides by 31.3. Okay, well, let me reposition myself here. Okay, now we've got a division problem. This is a calculator question. Let me move this, guys, so you can see me. This is a calculator question, but I don't have a calculator. You may not either. You never know. So let's actually do the division. 31. And I'm going to go ahead and immediately move the decimal place here. Add a 0 here. Okay. And let's do it. 313. How many times? So we're going to do 9. I already know the answer. It's 984. 9, so it's 27 plus 90, 27, 90 plus 27, 28, 17. I'm trying to do this as fast as I can mentally, but you know. 10, 3 without making a crazy mistake. 2, 6, 3, 0. Yeah, it's probably 8. Okay, 8, because I can see it in the answer. 24, 2504, I think. And then 2, 10, 6, 2, 1, 0. Is this exactly 4? No, it's approximately. I already made a mistake. And then this should be 4, which is 12, 40, 52. You know, it's close. But 984, it may have come out to be exact, I don't know. But it's about 984. It's got to be the right answer. All right. You see, these aren't that bad. I mean, honestly, these are a lot easier than the last ones that I've done in the last week, I'd say. In terms of when I say easy, look, it's hard if you don't know the steps. It's hard if you don't know how to actually do it. But if you know the steps are pretty short. You just set up a proportion and cross multiply. You know, if you had a calculator, it'd be even easier. You probably do these problems in 30 seconds. All right, last one of the day. We're almost done. A clothing warehouse houses about 14,000. I just hit my funny bone. 14,000 garments at the beginning of the year. Throughout the year, a small percentage of the garments became lost or damaged and must be replaced at the end of each year. Each year, about 1.5% of the garments become damaged, but not lost, and 0.6 become lost. How many garments must be replaced each year due to loss or damage? Okay. What's the total percentage that are lost or damaged? Well, it's 1.5 plus 0.6 equals 2.1%. Okay. So 2.1% of these garments are lost. How do we calculate 2.1% of 14,000? Again, I'm going to convert this to a decimal, 0.021, right? We just moved that decimal over twice. And then multiply it by 14,000. It's so good. 0.2021 times 14,000. This is going to be great. Watch. 0, 0, 0, 4, 1. Again, this is a calculator section, so 0, 0, 8. Probably should use one. That's all we got to do. 0, 0, 0, 4, 9, 2. And then we go 1, 2, 3. 294. What? Oh, about how many? So 290. Close enough. It's like I think I mentioned this yesterday. There's a reason why I don't use a calculator. Try not to unless I absolutely need one, like where it's totally ridiculous to do the math on paper. There's a reason, and it's because I'm a math teacher. I'm a math tutor, and I like to challenge myself. So hold on, let me see if I can turn this. Why is this camera off? I don't know. All right, something's up with my camera, so I'm just going to talk really quickly with this black screen, and then we'll adjourn for the day. I like to do the math mentally as much as possible because it makes me fast with my math. Like I'm pretty fast mentally, and it's because everybody asks me why. How are you so fast? It's because I practice all the time, every day. When I'm teaching, when I'm doing these problems, when I'm whatever, I'm always doing mental math, and it's gotten my mental math really, really solid. Like it was good in high school and college, it was okay, but now it's much better, and that's why. So if you're wondering, that's why I do it. Thank you guys so much for joining. I hope that was helpful. Again, please subscribe to my YouTube channel if you have not done so yet for more daily broadcasts of Khan Academy SAT problems and new stuff in the future. New math music video coming out next week. And email me if you have any questions. Huzaifa@Scalar Learning. I would love to hear from you guys if you have any questions, of course. Instagram folks, thank you so much for joining as well. And that is it. Take care, guys. Have a great day.